In this module, we're going to get into a great application of collision detection, especially in the world of platformers. Platforming games can be notoriously difficult to handle when you're dealing with the floating platforms and whatnot, because, how do you know when you walk off the edge? What do you do when you walk off the edge? How do you jump into it if you're jumping underneath it, and all these different types of scenarios. So what we're going to talk about here is what's called platform collision tests, and there's a lot of ways to handle it. I'm going to show you the most basic form, and basically what it's going to do is it's just going to extend upon our idea of box-to-box collision detection, which we already know. So we're just going to take that and we're going to use it repeatedly to create a good system. First of all, we need to realize that we need to be efficient. So our first step in our platform collision test is always to check to see whether the bounding box of the player collides with the platform at all. Once we know that it does, the next part is to say, well, we need to be a little bit more specific so we know what to do. Because basically what you have to look at it is you got to think about it like this. If you have a collision underneath the box, that means you bounced your head off of it, so you should be bouncing back down. If you had a collision to the right side of the platform, that means you should be bouncing back the other way. If you had a collision with the left side of the platform, you should be bouncing back to the right. If you had a collision with the top, that means you landed on the platform itself, which means you should be sticking the landing and staying on top of there. So you don't really move, it just kind of platforms out, which is great. And that's how you handle like ground and whatnot underneath at the bottom of the world as well. It's the same idea. The ground is nothing more than a platform. The cool thing about this is you're always doing this test. You're always saying, am I currently colliding with the platform? If I'm not, then gravity should be applied and it should start falling down until it collides with another platform. But I actually haven't shown you how to do this yet. How do you know which side of the rectangle you've collided with? Well, the way that we're going to do that is we're not actually going to test which side of the platform we collided with. We're going to test which side of the player collided with the platform. So if the right side of the player collided with the platform, that means I collided with the left side of the platform because I'm moving towards the right. Same vice versa for the right side of the platform. If the bottom of the player collided with the top, or collided with the rectangle, that means that I landed on top of it. If the top of the player collided with the rectangle, that means I hit my head off of it. But again, how do we know which is which? So this is what we're going to do. Step one. Where is it? Through here. Step one. Test for standard box-to-box collision between the player and every platform in the world. Why every platform? Because who knows which one he's possibly colliding with, he or she I should say. Who knows which one he or she is actually colliding with. Once you actually found a collision though, you shouldn't be testing. You probably, well, you might want to, but chances are you're probably not going to test against the rest of them unless they're physically touching platforms or whatnot, because you can run into problems with that. So step one, if you find a collision with that, then you go on to step two. You only do step two if step one was true. Step two means break up the player box into 4 parts. Head, left side, right side, and bottom. You're not going to need any more than that because the way we break it up you're going to see. And then finally, test box-to-box collision with these 4 parts. Depending on which part, so if collision exists, apply needed changes, such as reversing direction and moving position to be aligned with the rectangle, the platform. So basically, because of the speed that you're moving, it's possible that when you land on top of it, you don't actually land on top of it, your box actually is inside of it. And that's no good. So you would have to shift it up so it's directly in line with the platform itself. That way you don't get any weird collision tests afterwards. So these are our 4-step tests. So let's go back to step 2 though, because this is the most important part. And I'm going to draw it a bit bigger so we can see actually how to do this. So I'm going to draw my player. Perfect. And he's going to have some legs. Awesome. And I'm going to have him have a little bit longer arms than normal. And then we're going to have the major bounding box around the whole thing, which should be relatively tight. Well, it should be perfectly tight, but I'm doing my best to draw it on this with my free hand on the computer. Hey, nice. Now our job is to break this box up, and I'm going to use some blue here to show how we're going to break this up. The first piece is the head. Now you might just think, well, just draw a straight line across, and you got a head. Yeah, you do, but you have all this dead space now that isn't actually a collision. It's possible that that player is moving down on an angle like this, and that this rectangle passes through this corner without ever actually touching the player. So that's not actually what we want. We want to test for true collisions. So we're actually going to create a box that is the head. So we have a box for the head. So the next piece we need is the left side and the right side. So the left side and the right side, because of the nature of this, we are going to have some dead air because the arms are just kind of hanging out there in the middle of nowhere. So what we're going to have to do here is we are going to do a box that's going to cut it off in half over to the edges. And the same thing on the other side. So we have left and right. And then finally for the bottom, oops. For the bottom, it's going to be very similar to the head. There we go. Oops. So we have our 4 different pieces: our head, our left, our right, and our feet. Now, depending on the priority, obviously your feet should probably be tested first because that's going to be the most common one to intersect with the world, and then your sides, and then the head. And that's the priority order that you should be looking at. So basically, we're going to reverse this order. So 1, 2, 3, and then 4. So let's do that. 4 here, and then let's just change this to a 1. And that way we know which order we want to do that. So we have 1, 2, 3, and 4. Great. That's it. That's all there is to it. There's nothing special beyond that. The key is, how do you break up these boxes? Well, it's all broken up based on this box. So this box has an X, a Y, a width, and a height. Right? So you may have to trial and error this and eyeball it the best you can, but it's because you want it to fit certain things. You may want this box to actually be slightly smaller than the head, if it's got like like a weird hat on or something like that. It's up to you, because these are arbitrary data boxes. They're not drawn on the screen. In the demo I'm going to show you there, I'm going to draw them on the screen just for testing purposes so you can see them, but typically you don't draw them on the screen. And then over here, these boxes, they're going to start at a Y value that's the same as the end of this one, and their width is going to be half the width of the bounding box. Down here at the bottom, it's very similar to the head one, but its height, its Y value, starts where the body ones end. Again, just as the body ones started where the head one ended. And its width is going to be roughly the width of the feet, and again, you're going to have to play with that till you get it right. What I've done is I've done percentages, so I've basically said I want this box to be 25 or 75% of the width of the entire bounding rectangle, and this one's like 60%. Each one of these are 50%, and what happens is I get a nice perfect number. So you can play with that as much as you want. So this is the general algorithm of how to do it. There's nothing complex. It's just doing stuff that we've already seen, but actually applying it is a little bit more tricky, and that's what we're going to look at in the next video.